Good day, grade 12 learners. Welcome to today's technical mathematics lesson. My name is Moses Maudu. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So today we're still doing the prelim examination revision, and the topic today will be integration. So we'll be doing it topic by topic until we do the prelim the whole paper before we write the prelim exams. So we're looking at the integration. We've done integration before, but we just feel that we need to redo it again because this is a kind of a new topic in grade 12. So we really need to make sure that we get the 15 marks, plus minus 15 marks that is allocated to this topic. It is a very nice topic that we need to do. We've done it after we've done the differentiation, that is calculus. So this one we do it after calculus, and integration is just an inverse of differential calculus. Whatever we're doing in differential calculus, then we reverse it to get to integration. Just the lesson objectives. What is it that we need to know after at the end of this lesson, this session? We need to be able to can integrate the following forms of integrals. So in other words, we need to be able to say, if I'm given the integral of kx to the power of n dx, we need to know what is the procedure that we take when we integrate it. That is, the k will remain there as it is. Then the x, which is this x to the power of n, we're going to add 1. And then whatever we have added there, whatever the sum of that one, we then divide that by that particular sum. So if I've got n plus 1 there, I'll divide it by n plus 1, the whole thing by n plus 1. I must not forget that I must have the plus c. Remember, the n must be an element of real numbers, but n must never be equals to -1. What happens? When n is -1, there we get an undefined situation. So we get -1 plus 1, which is going to be 0. So we get an undefined situation, but we'll tell you what we're supposed to do later on. Now you'll see in the next one, if I've got k over x, right? So the k will be this side, but because of that, you remember if it's 1, that part here is a denominator, the x is a denominator. So we have actually a hyperbola graph. So once we have a hyperbola graph, we know that it has got asymptotes. Then we use the line graph. So we use the line. So the line of x, this is how we write it. We can write it with the brackets there. So if I've got a hyperbola, so in other words, I've got something with an x here, then I must write it as the line of x. So I must write it in this form. But the x value must always be greater than 0. It cannot be negative. Right. The next one there, if I've got an exponent as an x here, so I'll say the same thing there. So with a greater than 0. So when we integrate that, so we're going to integrate it in this form. Then we're going to have the a of x all over the line of a. So this part here must come here. So that's how we write it. So we'll have a to the power of x. X is an exponent. We'll write as the line, the a to the power of x. We write it as it is. But there we then write it as the line of the base. So it will be the line of a. So we must know that. When I have k x to the power of n, there's the same thing that we have there, and there is the same thing that we have there. So we must always be able to can integrate them in that form. So by the end of this lesson, every one of you must be able to can do it that way. Right. Again, at the end of the lesson, we must be able to can apply the integration. So remember, then we are going to get the magnitude of the area. Which area do you want to get? If I've got a graph, And then from there, I've got, for instance, an exponential function, for instance. So now I need to find the magnitude of the area included by a curve. If this is my curve, which is my maybe graph of f, and the axis of my curve. So in other words, and between the points. So let's say this is point A and this is point B. So, and I say this is the area that I'm looking for. So in other words, it is the area that is included by that curve and the x-axis. Can you see this is the x-axis? So this is the area that we'll be looking for, but it must be between the 2 points here. So you can see it is between the A and the coordinates that are given, it's A and B. Remember, the A and the B must be an element of integers. The sketch must be provided. So in other words, the sketch will be provided for you to be able to get the area, because you must see the area that you're going to be looking for. In this case, this is the area, this is the sketch, this is the area between this curve and the x-axis. It must always be between the x-axis, given the 2 points of x and the curve. Right. Now let's look at some exam questions. Now, determine the following integrals. Now, these are exam questions. So in an exam, I think question 9.1, we're going to look at questions that are based on indefinite integrals. So when we talk indefinite integrals, we're talking about integrals where we don't have the upper limit and the lower limit. In this case, you can see we don't have numbers on top of that integral sign and no number below the integral sign. So those are called indefinite integrals. So how do I get the integral, this integral, the first one, 1.1? Now, how do I do this? So I'll use the rules. Remember, for us to get the integrals, you must use the rules. The rules that I was talking about earlier. So remember, if I've got the integral of x, for instance, so the integral of x, right? Remember, this x must be the same there. This is the one that I'm integrating. So that the d of x shows me which letter am I integrating. So I'm integrating x. So the slices for x will be, so in this case, what should I do? I'll have x to the power of 1, I know. So remember, I must add a 1 and divide by whatever I have there, so it will be 2. So that will be my integration. Now, let's check this one. I have a 3, x to the power 3. So what do I do? On the exponent of x there, on the exponent 3 there, I'm going to add a 1. And whatever I get, that sum there, I must divide the whole x cubed by that sum of that exponent. So once I integrate, I can see that one can be integrated easily. Once I integrate, I'm putting an equal sign. Once I start integrating, I put an equal sign. Do not put the integral sign, and that's one mistake that we always do. So in this case, what do? We have x to the power of 3. Now I'm integrating. So I'm adding a 1 on the exponent of 3. Whatever I got there, I've got 3 plus 1, so I'm going to say 3 plus 1 at the bottom. Do not forget to add c, right? Right, because we need that c. We don't know what has been integrated, what has been differentiated as a constant. So that's why we always put a c for indefinite integrals. So in this case, there I'm going to have x to the power of 4 divided by 4, then plus c. And now, in this case, I have now integrated. If I want to differentiate this, I'll do the same thing to go back and differentiate. If I want to differentiate, I'm just going to write the differentiate so that I can show you that it is a reverse of the other one. So in other words, this is, remember, it's a constant. So if I want to differentiate that, let's say that graph is f of x. So I want to differentiate it. So I'm going to write it as f of x. I want to differentiate that. If I want to differentiate that, the 4 goes to the back of that. Do you remember? So it will be 4x. Then I subtract 1 on the exponent, 4 minus 1, and then divide this by 4. That's 4. So the 4 and the 4 divides, and then from them left to the x to the power 3. And remember, the differentiation of a constant is 0, remember. And that will be the same as what we have there. So differentiation, integration is just the reverse of uh, differential calculus. So it's the same thing as exponents and logs. You know, if I need the exponent, I can change from exponent to log, and I can change the vice versa. So in this one, we can still do the same. I can integrate and then differentiate also to see if those two can give us the same answers, what we started with. Now let's look at 1.2. So 1.2 is the same thing, but I'm not going to do the differentiation part. Okay, right. So 1.2 is the same. So I've got x squared and I've got a 4. So let me first do this before I integrate. Let me first do this and write this one as 4x to the power of 0, because I know that x to the power of 0 is 1. 1 times 4 is 4. So I still have the same thing for the x. Let me check this. Which letter am I differentiating? It's x. So now I'm going to come here and say, okay, this is going to be x to the power of 2 plus 1 divided by 2 plus 1 is 3. So I'll have that. Then I come to the next one, then I integrate this one. So it will be 4x, 0 plus 1, and 0 plus 1 is 1. Then I must not forget, because I'm integrating now, I must put a plus c. So then I'll have x to the power of 3 all over 3 plus 0 plus 1 is 1. So 4x to the power 1 divided by 1 is 4x. So my answer will be 4x here. Must not forget to put the c there. So that is the integral of what was given up there. Okay, and these are basic questions that we get in question 1. The one thing that we must understand in question 1, and I know you know what you're supposed to do, is the simplification, and it is the exponents. It's very, very important. Simplification and exponents. Algebraic expressions must be written in the form where it can be integrated. Right, now let's check what I'm talking about here now. In the next one, determine the following integrals. These are still indefinite integrals as long as we don't have the numbers, the upper limit and the lower limit. Now, the integral of the square root of x, we are still working with the x. Now, what should we do here? I cannot integrate it in that form, so what should I do? I must first, when I'm simplifying, I still keep the integral sign. So therefore, I'll have x to the power of half dx. Now, when I have a square root, it's x to the power of half. If I've got a cube root, that will be x to the power of 1 over 3. So remember, this is 1. The root becomes the denominator of that exponent. Fifth root of x will be x to the power 1 over 5. So we must know that. Now, this is because we don't write a 2 on the square root, so that we write 1 over 2 as a denominator. I haven't integrated. So what should I do now here? I must then integrate. How do I integrate? X to the power of half. I'm adding a 1 here. At the bottom, I'm adding a half plus 1. Then I'm adding a c. Very, very important. Don't forget that c, because you will be penalized if that c is not there. Then we have, I know we have problems with the fractions, and you have a calculator, please just put it on a calculator. Half plus 1, 3 over 2. So which means that x will be to the square root, to the power of x over that, and this is divided by the same thing there, 3 over 2 plus c. This doesn't look fine. That fraction 3 over 2 there, how can I work my magic here? So therefore, I see it's 3 over 2 here. So I want to take it up there. So how should I write it? I know here it's a 1. So if you take a calculator and say 1 over 3 over 2, then you're going to get an answer of 2x to the power 3 over 2 all over 3, then you just add plus c there. I don't think the examiners will be very harsh on this one. They can still give it to you, but let's write the correct mathematics. So the correct mathematics is writing it as 2x to the power 3 over 2 over 3 plus c. And there's the correct mathematics. Okay. Right. Now we go to 1.4. So 1.4, you still remember when we said when we have the integral of k over x, so dx, that in this case, what do we have? As long as the x is a denominator, in this case, we have k over x as a denominator, then we are going to write, this can be written as k multiplied by 1 over x dx. You can see I'm keeping the integral sign because I have not integrated. So once I integrate, then I put this. So it will be k. Once I see 1 over x, then I just know it's ln of x. And that is plus c. So I'm going to do the same things as we have done there. In this case, what do we have? 1 over x. So I'm going to say this will be the same as 1 multiplied by ln of x. All right. That one is not necessary. I'm just writing it down because I have it there. So if I've got a 7 there, so I'm going to write a 7 here. If I've got a 12 there, I'm going to write a 12 there. So please, in an exam, you can just write ln of x, or you can just write 1 ln of x, doesn't matter. And then that is plus c. Right, don't forget the plus c. Okay. As simple as it. So you just write it like that. Okay, an easy one. All right. Okay. The next one in 1.5, we want to use the rules also for this. Now, there you have 3 to the power of x plus 3 over pi. I'm still integrating x. So when I see pi, I cannot integrate that pi because it is not what I'm requested to do. What I must integrate is the x. Now remember the 3 to the power of x, we said, if I've got a to the power of x, I must write it as the integral of this one will be the same as, let me write dx here, because that's very important, it will be the same as a to the power of x all divided by, remember it must be ln of a base, then that will be plus c. So in the 1.5, we have the integral of 3 to the power of x plus 3 over pi dx. So what should I do there? I'm going to integrate because I don't see where I need to simplify. So I don't need to simplify anything there. So I need to integrate. So if I integrate, then I compare this one with that one. So we're going to have 3 to the power of x all over ln of 3. That's how we're going to write it. Now, plus. Remember here there is an x. Please, there is an x. If I've got 3 over pi, this one will be the same as x to the power of 0. There is an x. In any constant, there's an x, but that x is raised to the power of 0. So which means that I'll have 3 pi x to the power of 0, okay? X to the power of 0, then plus 1. Remember, the whole thing there must be divided by 0 plus 1, which is 1. Then I must not forget to put a c here. So my answer will be 3 to the power of x over ln of 3 plus 3 over pi x to the power of 1, then plus c. Remember, there's a difference between 3x over pi and 3 over pi x. This is the same thing as 3 over pi x. So these two are the same, but this is not the same as that, because that x here is a denominator, and in this case x must be a numerator. In this case here, the x is still a numerator, because you are saying 3 pi multiplied by x, which gives you 3x over pi. But if I do that, that will be incorrect. And these are some of the mistakes that we get in the exam. Please try to avoid them at all costs. So if you want to multiply the x, it should be 3 over pi times x, which gives you 3x over pi, because this is x over 1. So the 3 times x is 3x, pi o times 1 is pi. Okay, so these are just the basic things that we need to iron out before we write our prelims, so that we don't lose marks unnecessarily so. So this is the final answer for 1.5. Okay. All right. Now let's look at the ones where we have the combination of the of these, where we need to simplify, and then where we need to try and see if we're able to can factorize and all that. Okay, now let's see in this one. Now you have x to the power minus 2 plus 1 over x of dx. So here you can see the combination of those two. So first of all, in this case, I don't think I need to simplify anything. That's simple. I need to just go directly to that. Please watch what I'm doing. I'm saying once you start integrating, you cannot integrate one part and then from there simplify the other and write an integral sign. If I integrate, I must integrate everything. So in this case, because I want to integrate everything that is there, I put an equal sign. Once you put an equal sign, do not put the integral sign. Now here in this case, what do we have? X to the power minus 2, so I'll have x to the power minus 2. Remember, I'm adding a 1. So in integration, we add 1. In calculus, we subtract 1. So this is over, I put that same thing there, then plus. Now 1 over x. 1 over x is, remember, it's ln. So this should be ln of x. Then we must put plus c. Never, ever, ever forget the c. So here we're going to have integral of x to the power minus 2 all over minus 1 plus ln x plus c. Okay. So in this case, as I said, I don't think the examiners will be very fussy about it, but let's write the correct mass. So what will be our correct mass? The correct mass will be negative x to the power minus 2 plus ln x plus c. Okay, right? But I know some of you might think, I don't want to start with a negative sign. So you can start with the ln of x, then minus x to the power minus 2. If you want to show off, sometimes we need to show off in this mathematics. You want to show off, you want to show that the examiners that you are able to understand what the meaning of that x to the power minus 2, then you can just write this minus 1 over x squared and then plus ln x plus c. That's one you want to show off, to understand that I know that if I raise something to minus 2, Then I can write this a denominator with a 1 minus 1 on top. Then from there I can have that. But that is not very necessary. We can still leave our answer there, but if you want to show off, you can still do that. Okay. Now, this is another one here. I know. And one thing that I know each and every one of you in the province, you are able to integrate. But when it comes to this one, you want to show that you are able to integrate and do wrong things. You know, some of you will come here and say +1, and then that one is 1 plus 1, and then you can't do that. So you really need to look at this and first factorize, first simplify this, because this is not simplified. So when I'm simplifying, I'm not going to let go of the integral sign. So meaning that my integral sign will remain divide x squared. Okay, sorry. I must factorize the top part. So I'll have x plus 1 and I'll have x plus 1. And that is how I factorize the top one. I can see the factors of 1 is 1, and 1 plus 1 will give us a 2. At the bottom, I'm having x into x plus 1. Because if I leave the top one, I factorize the top one and multiply out the bottom one, I'm just mixing up things. I'm just going in circles. So in this case here, the x plus 1 and the x plus 1 will divide. Then we will have integral of x plus 1 all over x. Can you see I'm still keeping the integral sign? Not letting it go because I have not yet integrated. So now here, what do I do? Just want to show you this. If I've got 2 plus 4 over 2, that's easy. It's 2 plus 4, it's 6, and 6 divided by 2 is 3. But if I want to split this, I can split it in this form. Let's see if we'll get the same answer. If I split it in that form, it will be 2 over 2 plus 4 over 2. So 2 over 2 is 1, 4 over 2 is 2, 1 plus 2 is 3. So I still get the same answer. So if I split that, I still get the same answer. So for me to be able to integrate this, I must split it. So how do I split it? I'm going to split it as x over x. So in other words, I'm going to split it like this, plus 1 over x with a sign, okay? So it's 1 over x. Then that will be dx. Can you see I have not yet integrated? I'm still trying to simplify it so that I'm able to integrate it. Now, in this case, I'm going to have 1 plus 1 over x. Then I can see I cannot simplify this further. So I need to integrate. Then for me to integrate this, I'll then say, now this is equals to. Remember, 1 is the same as x to the power of 0, right? Then I know that this is plus ln x, and that is plus c. So that's what I'm going to get, right? Now, then I know this is, remember, so it's 0 plus 1, right? So now remember, this is x to the power of 1 plus ln of x plus c, and that is my integral. So my integral will now be x, remember that is divided by 0 plus 1, which is 1. You don't have to write it. Once you've done a lot of them, you'll see that, the constant will always have an x. You see, every time you can see, the constant, 1 is a constant, so it will always have an x. So every time you're doing that, then you'll be able to figure out what you're going to have, okay? So that is the integral of that. So you can see from this, we went to this one by simplifying. Then once we start integrating, drop the integral sign. There's the trick. Integrate, drop the integral sign. Okay, right. Now that is my lovely integral of that complicated thing. So we can now get full marks for that if we are able to can do the integration. Okay, now here's another one. Same thing. We can go and integrate this part, this part, this part, this part, and that part. No, we can't. So first of all, simplify. How am I going to simplify this? Easy. Same way as I've done with the 2 plus 4 divided by 2. Remember that I can just, each and every term can be divided by the denominator. Okay, and that is what we have done. Remember when we were adding fractions, we know that if all the denominators are the same, we just write the numerators together. And then we just sum the numerators and then we keep the denominator as it is. Okay, right. Now in this case, same principle. So I'm going to have, now, first of all, I'm keeping the integral sign. Then each and every term will be divided by x. So I'm going to say x cubed all over x plus 2x squared all over x plus x all over x minus 2 over x. Then the whole thing there is yet to be integrated. Now I have all this. So you can see I can take this one back because the denominators are the same. Add the numerators, sum up the numerators. So in this case now, I have not yet integrated, keep the integral sign. So what do I have inside there? So I'll have x squared, that is this divided into that. That one, it divides there, we get 2x. This one divides there, we get plus 1. That will keep it as it is of dx. All right, so now we can integrate. Now, how are we going to integrate here? Okay, now, the first thing that we're going to do is we're going to write down the equal sign. All right? Now, what is the integral of x squared? By now, everyone must be able to then quickly do it. You know, in the exam, once we've done 5 or 6 times, you're quickly going to do that. So, but for those who are still struggling, it will be 2 plus 1 divided by 2 plus 1, which is 3. Plus the integral of that, it will be 2x, 1 plus 1, 1 plus 1 is 2. Then we have plus 1. Remember, constant, we just put an x. Minus. Once we have an x as a denominator, don't think. 2 must be there. Then we have ln of x. Don't forget our friend here. That friend c must be there. Every time you must put a plus c for indefinite integrals. So let me just write it properly there, x to the power 3 over 3. I know that 2 and that 2 will divide each other there. Then I'm going to have x to the power 2. Then the x will remain. Then the minus 2 ln x will remain. And that is plus c. And that's how we get our integral. Remember, it is from here. If I take the derivative of this one, the derivative of this one will give us something like that. Okay, right. Right, remember we're not going to give you a derivative of that when we have the 2 ln of x. Okay, so now let's stop at that. That's what we're doing now, which is the integration. So we integrate up to then. So we leave it there. Okay, right. Now let's get to these nice ones. I love these two because it's quite easy to do these ones. Very, very, very easy. Let's check. It's 2 to the power of x. What do I know? The x is an exponent. No problem. What must I have? 2 to the power of x over ln of 2. Don't forget, don't put ln of x. Okay. So that is, and then plus c. That's all you do. 2 marks. 1 mark for this ln, 1 mark for the c. If you don't put a c, then it means that you're going to get 1 mark only. Only. So don't forget to put, it's just a mark, it's a simple mark that everyone must get. So we go to the question 9.1.1 and 9.1.2, those two questions there, they deal with the indefinite integral. Then you must be able to can do that. As long as you don't have any numbers on top, the upper limit and the lower limit, just know that there is a plus c that must be added. Okay. All right, 3.2, the combination of your exponent and your hyperbola graph. So in this case, remember this is an exponential graph, this is a hyperbola graph. So we just need to integrate this. So integrate is nothing else but, determining the area. But in this case, it's just getting the integral without the upper and the lower limit. Once we get the upper and the lower limit, we are able to can get the area of that. Okay. Now, by using slices, but in this case, if I've got a 2 and a 3, I can apply integration by substituting those two values. Right. Remember, it's just an approximate area that we're getting here. In this case here, what are we going to get here? We're going to get 2. 5 to the power x is similar to this, so it will be 5 to the power of x all over ln of 5. Okay, then we need to do that next one. 1 over x, everybody knows, it's a ln of x plus c. And that's all we do. That's why I say I love these two. Easy, straightforward. No challenges in terms of that. We must be able to can do that quick. So once we have this, we must be able to can easily do that. Right. Now here's this one with an x and a y, and the x and that. And you're wondering, wow, what should I do now? If this question was find the following derivative, then here they wrote dy. So I'll only look at the y. But in this case, they say dx, so I'll only look at the x. So there's only one term with an x. That number here, the one that we're having here, it's our constant. So what do you say about the constant? We just add the value of x. We just add x on the constant. Every time you see a constant, you just add an x when you are integrating. So if they said dy, so my x to the power 5 will be my constant. But that's how it works. Okay. Now, maybe we should add a question on that. Now, in this case here, I am now integrating. So it's x to the power 5 plus 1 all over 5 plus 1 is 6 plus 2xy. So I just add an x there. Or someone can say yx, it doesn't matter. Xy and yx is the same thing. And then that will be plus c, because it's a constant. So there I'll have x to the power of 6 all over 6 plus 2xy plus c. And that's my final answer. I just want to quickly add this question here. If I've got this and I've got x to the power 5, then plus 2y, then this is dy. So you see now I'm integrating y. I'm not integrating x. Right? So what should I do here? So I'll then say this is the same as x to the power of 5 multiplied by y. Then that is plus 2y, 1 plus 1 all over 2, then plus c. So I'll have x to the power of 5y, and then plus the 2 and the 2 divides, we're going to have y squared plus c. So please make sure that you check here, what is it that you are integrating? Because sometimes, these examiners can just put pi and then from there, or a or b, and from there you then go for x, and then because every time we were doing it with an x, please be careful of those type of questions whereby first check what is it that we are having there, so that then you go and integrate the correct letter that has been given. I hope everyone is taking notes on this one, and you must make sure that you practice all this type of questions, so that you don't get shocked when you get something there and then you're thinking, why? We were always in class, we were always doing it with an X. Why are we now having y in this instance? Please know the process and read the question and understand what the question wants, so that you answer exactly what the question wants. Sometimes we lose marks because we don't read the question, we're just doing as we know that we have seen, I've seen this one, we're able to can do. Don't hurry in the exam. Please make sure you understand exactly what it is asked and answer exactly what is asked by the examiners. All right, now let's look at what we call the definite integrals. Now with the definite integrals, here the interval is given, which means that when we integrate in these polynomials, we will have the number there and a number there. And the function will be there, and we have our dx. Now, the b is called the upper limit, and the a is called the lower limit. Now, you'll find that the function, when we integrate, remember this is a gx, it has been integrated to an f of x. So we'll have the b on top and the a there. So how do we do? Once we integrate it, then we put these brackets like this. Then whatever is integrated will be here, and we put our upper limit and our lower limit. Then how do I work out this upper limit and the lower limit? Then I must now have two brackets there, and I subtract. So I subtract the lower limit from the upper limit. So it will be the upper limit subtract the lower limit. So in this case, you can see f of b is the upper limit, and we subtract the lower limit. The most important thing here is to work with brackets, because once you don't put your brackets correctly, the negative, remember, affects what is inside the bracket. It's your stop sign. So you stop and look what is happening in the bracket. So I stop and look. So that negative there is going to affect whatever is inside that bracket. And that's where we get things wrong. When you're doing this one of the questions here, you'll see what I'm talking about here. So very, very important that you know when we're working with definite integrals, there is that rule that we're going to use where we subtract the lower limit from the upper limit. All right, now let's check what I'm talking about. Determine the following definite integrals. So when we say definite, means that we're having a number in there and the number there. In this case, it's 3x. So we're doing the same thing that we were doing, but now what has changed is that now we are substituting. That's important. So here, once I start integrating, in this case now, when I start integrating, I'm no longer going to put a c. What is the reason? Because now we're talking about the upper and the lower limit. No c when we're having definite integrals. We don't put a c. So in this case here, we're having a 2 and a 0. Let's integrate this one. So it's 3x to the power 1 plus 1 all over 2. So I'm going to have 3x squared all over 2 with that 2 and a 0. Am I done? No, I'm not done, because now I'm going to have upper limit and lower limit. So what should I do? I must use my rule. What is my rule? F of the upper minus F of the lower. Right? So it will be F of 2 minus F of 0. So I'm going to do the same here. So I'm going to say, must put brackets, love brackets, minus this. I always want to do this. When you're practicing, I always want you to put a 2 and a 0 there. That's when you're practicing. So that then you know which value are you substituting with. In the first one, what should I substitute with? I must substitute the value of x by 2. In the next one, I must substitute the value of x by 0. That's all. From this step, I know we always make a lot of mistakes, but from this step, you take out your calculator and put these values as they are in a calculator. In other words, you're starting with your bracket, fraction button, 3, open bracket, 2, close bracket, squared, divide by the 2, close the bracket. Now, this 2 here is not a square. I know, sometimes it will confuse most of you. It is the number that we are substituting by here. Because I know once you put that, then on your calculator, you're going to say close bracket squared. And that's where you're going to get it wrong. Right. Right. Now, then from there, once you have done that, then I think here it's going to be 2 squared, it's 4. 4 times 3 is 12. 12 divided by 2 is 6. This is 0. Divided by 2 is 0. So it will be minus 0. And our answer is going to be 6. So that's what we're going to get. Okay. So now we've got a definite integral. We know now when we determine the definite integral, we must have a value. And that value in this case is 6. Because it is between two limits, which is the upper limit and the lower limit. It's between the two. So we're going to get a value here. In this case, the value is 6. Right. Same principle here that we're going to apply. And now we have got 2 over x. Now let's see what we're going to do. This is very, very interesting. Very interesting. I love this. Because that's when you know how how to use the lim. Go into your calculator. I know some of you are using calculators that that are not upgraded. Those old calculators. Please upgrade your calculators before the prelim so that you get used to it now. Then from there, my calculator has got a lin, so I'm going to go to my calculator and get a lin function. Then I'm able to use the lin function, because this is where you're going to use your calculator for the lin function. So here, I'm going to then, first, let me check if I need to simplify. I don't think there's not anything to simplify. So I'll just go directly to my diagram there. So I'm going to have 5x squared. So it will be 5x 2 plus 1 divided by 3 plus, if it's that, it will be 2 ln of x. This is a 3 and a 0,5. Must write those two. Then obviously that one will be 5x to the power of 3 all over 3 plus 2 ln x. Do you see I'm not writing a c, ne? So it's 3 and 0,5. Okay. Now, what is the next step? Very important. You go there and do 2 brackets, subtract that bracket. Okay. The first one is the 3. I substitute by 3. So I will have 5 into 3 cubed all over 3 plus 2 ln 3. So the x is no longer there. It's substituted by that number. So here, what should I substitute by? So I'll say 5 into 0.5 to the power of 3 all over 3 plus 2 ln of 0.5. All right, straight to the calculator. I do not want you to do 5 to the power 3, then get 27. You say 27 times 5 divided by 3 plus 2 ln. So you go to your calculator and then you say 2 ln. There's ln on your calculator. So if you don't know where it is, please go and look for it until you find it. And so that then when you go to the exam, then you know where it is. Right, 2 ln of x of 3 in this case. Then I think the answer gives you 2,197. I don't want you to go and do it piece by piece. You put everything on the calculator and the calculator will give you the answer. Please, you must check me. My answer that I got was 48.4. That's what I've got, which is a positive value, 48.4. That is what I got. Please check my calculations there. But make sure that the batteries of your calculators are fresh, new. When you go into the exam, we don't want you to get disappointed. And please don't borrow a calculator. I always say, don't borrow a calculator a day before the exam, because the calculator that you must use in the exam must be the calculator that you've been using when you're practicing. And that makes life easy, because if you borrow a calculator a day before or on the day of the exam, that calculator might be on the wrong mode, and then from there you get wrong answers. Right. Let's get on to the next one, which is quite straightforward, and this one is quite straightforward and easy. First of all, I know I'm now going to write this in. It's 2n minus 1. So now the differentiation of that, it will be, I'm not going to waste time here. It's 4 plus 1 is 5, and that is divided by 5. Then from there, you get your two brackets, f of upper minus f of lower. F of upper, it's 2 to the power of 5 divided by 5. And this one is 2 to the power minus 1 divided by 5. The other one we substitute by 1. Oh, by 2. The x there must be substituted by negative 1. Sorry, that's my mistake. Mistake there. So it means that if one, I must substitute that one by, the x must be substituted by minus 1, and that is raised to the power of 5. My mistake, sorry. Right, so now x is 2, so it's 2 to the power of 5. X is minus 1 is minus 1 to the power of 5. And that is 32 over 5 minus, then it must be minus 1 over 5. So I'm going to my calculator now and check quickly. It's a fraction button, so let's do it together there. So it will be the fraction button, which is 32 divided by 5. Then from there, I'll go there and say negative and negative, it's positive, so I'll just summarize positive fraction button 1 over 5. Then from there, I get my answer. My answer there should be 6,6. Okay, so my answer there will be 6,6. All right, easy, straightforward. We must be able to do that, this type of question. Now, the next question, it's where we need to first simplify. So we must first simplify, and we have done a lot. We've done 3 of them already. So I don't think we can waste a lot of time on this one. We've done 3 already. So what do we do here? We are first going to write them down without integrating. So we're going to have x squared over x plus 2x over x minus 1 over x. Remember, we are not differentiating, we are not integrating yet. So therefore, I'm not yet integrating. Then I'll have x plus 2 minus 1 over x. All right, that's what I have. Now I can start integrating. So I can then say this must be integrated. So the integration of that will be x squared over 2. I hope you now understand how I'm going to get it. 1 plus 1 all over 2 plus constant, we must have an x. 1 over x, we must have the ln of x. Great. Then we now go to the two brackets, the f of upper minus the f of lower. Right? So we're going to have the lower, we're substituting by 2. I mean, the upper, we're substituting by 2. So it will be 2 squared over 2 plus 2 into 2 minus ln of 2. Right. The next one will be 0, 0.5 squared all over 2 plus 2 into 0, 0.5 minus ln of 0, 0.5. Right. Okay. Then straight into the calculator. You must not waste a lot of time into this. You must go straight into the calculator and then so that we do not waste time on that. So 2 squared over 2, that's fine. So we substitute by 2. Here we substitute by 0, 0.5 squared, 0, 0.5, 0, 0.5. So on that, the answer I think was 3,48. I think I got 3,48. Please, you must check me. For the 3.48, it will be the answer for the definite integral of it. So make sure that we must make sure that we understand how to do that integral. All right. Now, the next question here will be to get the integral of an exponential function. So here I know that I do not need to simplify this. So it's 3 to the power of x all over ln of 3. And then I don't write plus c, remember? Then I have a 0 and a minus 2. Okay. All right, so now let's get to the next one, the next step. What do we do here? F of the upper minus f of the lower, right? So then we have 3 to the power of 0, all divided by the ln of 3, right? Then here what do we have? 3 to the power minus 2, all divided by the ln of 3. Okay, then we get to the answer. So that will be 1 over ln of 3, and then that answer that we get will be 0, 0.81. Okay, so 0, 0.81. Remember, it's an exponential function between 0 and that. If I can just draw a picture of this one, so it will be between 0 and minus 2. So in other words, we're looking for that part here. Remember, when you talk definite integrals, we're talking nothing else but the area. Okay. When you go to the area, I'll show you what I'm talking about. So we're just talking the area of that part. You can see that the graph, that space there can be, the area can be 0, 0.81. Okay, all right. Because this value there is decreasing between 0 and 2. Okay. Now, here is the section on the area that I was talking about. That now we need to look at the area that is bound between by a curve and the x-axis. So remember, this is the curve, that is the x-axis. This is the curve, this is the x-axis. So it is the area that is formed between the x-axis and the curve, okay, or the graph, for that matter. Right, now, the areas above the x-axis, please, this is very important. the areas above, the keyword there is above the x-axis, then the formula will be that. And we have been doing this in the past exercises that we have been doing. Now, if you check the areas below, these are the key. The area below the x-axis, it becomes, there we have a negative. We put a negative there. So the A1 here is the area below the x-axis. Can you see? And this one, A2, is the area above the x-axis. So on all the questions that we have been doing previously, the area that we were getting, the values that we were getting for the definite integrals were positive, which meant that we were only doing the area above the x. So we'll have a question where we do the area below, and then you can be able to see how we then going to deal with that negative. Okay, so that then we are able to get the correct area, because the area below, remember, area is the amount of space there, né? Is the amount of the of space that we have. So we cannot have that amount as a negative value. So the area will always be positive. I know it's some of you have been taught that if you get a negative when you're dealing with this section, you must just put it as a positive. Then you ask yourself, why say? It is because of that negative there from this statement. So from that statement, we're saying the area below must be indicated with a negative. So that's why we're going to have a negative. Right. So now, let's look at that question. Before we look at this question, can we take a 2 minutes break? And we'll be back. Okay, welcome back. Now, you can see all those questions are put exam type questions, taking them from past papers, and this is how the questions are set. Now, the sketch below represents the graph of the function. We must read the statement every time. This function there is represented by f of x equals to 2x plus 3. Determine the shaded area bound by this and the x-axis, by the curve or the graph and the x-axis. Now, when I go to the sketch, the x values are given, so I do not have a problem. I have the lower and the upper, which means that this one will be the upper and this one will be the lower limit. So it means that now my first thing that I need to do is to write the integral sign. So my integral sign with an upper and a lower limit the function is 2x plus 3, and then it must have a dx. Very, 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 very important that I do that, so that I'm able to can work it out. Now, the next thing is to integrate this. So I'll have, by now, I hope we all understand what we're going to be doing. It's plus 1 divided by 2, so it will be, I think, x squared. Then that is a constant, it must have an x. So here I know my boundaries are 1 and minus 1. So the next step is to then have my upper subtract the lower. Then we have the final answer. So now I'm going to have the x will be substituted by 1. Sorry. X will be substituted by 1 first. Then we substitute by negative 1. Right. Then from there, we use a calculator directly with the calculator, and that will be 6 square units. Now I'm talking area, it must be square units. Now, look at this. This area that I'm getting here, the x-axis is here, the area is above the x-axis, then this thing here is positive. So we said above the x-axis, the area will be positive. Below the x-axis, the area will be negative. But the x-axis is there, the area is above there, so it's positive. Okay. Now, what is another way of getting the area of this? Obviously, is to get the x-intercept here and get the distance of that and get the y value there, get the distance of that. This is 90 degrees. Then we can use the area equals to length times spread. But for now, because we're doing integration, we're doing it like that. If you do it with the length times, but you can go and try it on your own. The length of this line will be 1 substituted there, which will be, I think, 5. Then from there can get the length of that. Okay. Then from there you can just put them together, and then you're going to get a 6 for that matter. Okay, you can go and try it on your own there. Right. Here again, we're talking the area above that, which means that the answer is going to be a positive value. But let's check. First of all, what do you write? We're writing the integral sign. It's from -1 to 4. My upper limit is 4. My lower limit is -1. The integral 3x plus 4, and that is dx. Very important. Right? Then from there, we're going to have our integral. So now I know it's 4 and -1. Then I integrate that. So what will be the integral of that? It will be minus x cubed over 3 plus 3 over 2x. It's squared, yes, then plus 4x. No c when we are having indefinite integrals. Now from there, then I have to expand it. Then I have to have my f upper minus my f lower. Then we write down the final answer here. Calculator usage, very important. So here I'm going to substitute. Now the substitution is very, very important. See learners not substituting correctly, especially when we have a negative sign. So here it should be negative open bracket 4 cubed. The negative cannot be inside the bracket, please. All over 3 plus 3 over 2, 4 squared, plus 4 into 4. Okay, right. In this other bracket, it will be the same, negative into negative 1 cubed. So the negative must be out. The other negative is the one that we're substituting with. All over 3 plus 3 over 2, negative 1, plus 4 into negative 1. Okay. All right. Then from there, you put this into bracket. I know with the fractions and this and this, and then we tend to make some mistakes. You must be very careful. If you want to be very much correct, you can do the first bracket, then you put the answer, then you do the second bracket, you put the answer, and then you subtract the two. But because I've done everything, put brackets, I've done everything by using a calculator, of which the answer that I got was 20,83 square units. We are talking area here, so there must be units. But we must write units, my boys and girls. We really need to always write the units. Okay, because you might be penalized for units. Please write the units. It's units squared because it's area. Remember, area, length times breadth, or half base times height. The area of all this, it's two-dimensional. Anything two-dimensional, it's squared. Anything three-dimensional like volume, it's cubed. So with area, it's always squared. So you must write your units. Okay. Right. Another exam question. This one was made very easy. The examiner was very, very, very friendly with this question because he took that question and then broken this question down into smaller questions. They didn't just ask you to determine the area. So what they did was to say they wanted to test if you understand each and every aspect in going to find the area. I love this question. The sketch below represents the graph defined by this. Then the examiner said, determine this. In other words, they're saying, just write down the integral of that without having the upper and the lower limit. So, integral of that. I love this question. And he said, now from here, what do we have? 5 ln x. That's all that the examiner wants. So, that's what he wants. But you can see the questions that follow will direct you towards finding the area that is bound between these two values. Can you see those two values are not there here? You're only getting that. So that's it. So the next question, look at the next question. Now, hence, determine this. So what is the examiner saying? We already have this part here. Can you see? We already have the integral of that part because we know the integral of that part was 5 ln x. Now, the examiner is saying now, please put those big brackets and put a 3 and a 0,7 and get the values. See, so now getting the area. But at least you have that 1 mark from that question because you know how to do that. The next mark that will go, it will be to put in those boundaries, the upper limit and the lower limit, the upper boundary and the lower boundary. So what do we do from here? 5 ln 3. What do we do then? 5 ln 0,7. I know my boys and girls, this question you're going to get full marks, 50. I have confidence in this. What you're going to do there, what are we going to do there? We are now going to work out that part of the question by using a calculator. So you go to your calculator, then can you see that this area is also above? Oh, what do I have above? Why don't I have below? Okay, we'll check. This is above, so the answer will still be positive. So the answer that we're going to get is 7,27. Don't forget the units, it's area squared. Okay. All right, 3.3, still same question. It says, what does your answer in 3.2 imply? I love this. What does this answer that you got, that 7,27 square units, what does this question imply? What does it tell you? The question, what does it tell you? I can hear some of you saying, oh, that's easy, we're getting the area. Okay, that's correct. We are getting the area. Which area are we getting? the area bounded by the curve, and the x-axis, where x is equals to 0,7, which is the lower, and x equals to 3, which is the upper. So they're just asking you that answer that you get, what does it say to you? It says we're getting the area bounded by the curve. The curve is this one here. Here's our curve, and the x-axis, this area. But this area must be between what? 0,7 and 3. It is not there. It is not there. We're not talking there. We're not talking there. We're talking there. The area, the shaded area in this case. You can just say the area, the shaded area bounded by the curve and the x-axis. Actually, you must put that because now that part is shaded. But you cannot just say is an area of the shaded area. I mean, is the shaded area. You cannot just say that. You must tell us that you understand that there is the area bound by the curve and the x-axis where the x values are 0.7 and the answer is already there on the sketch. Okay. Right. Oh, I love it. This is what I was looking for. Wow. But it is not there. The area now, can you look at the area now? The area is now below the x-axis. Now let's see what will happen. The area is now below the x-axis. Can you see? Now, what do you know when the area is below the x-axis? First, let's do what we're supposed to do first. Now, first we must write down the integral sign. So we must have our upper boundary is 3, lower boundary is 2. We are having x cubed minus 6x squared plus 11x minus 6 dx. Let's now integrate. Integrate x to the power of 4 all over 4 minus, if I integrate that, I think I've integrated somewhere, so it should be 2x to the power of 3, and then that should be plus 11x squared over 2, and then that will be minus 6x, and then from there, then I'll have my upper boundary and my lower boundary. What is missing in this one now? My missing part is the negative. Why? Because I can see that the area is below the x-axis. Once it is below the x-axis, please. If I had this one and they also asked me this one, then I'll do them separate. Okay, right. In this case, they've asked me 1, which is below. So the minus must be there. So I'll have a negative sign. Yeah. All right. Now remember that negative sign means that it is a negative for everything. So it is the negative for everything that I'm going to be doing here. It's a negative of everything that I'm going to be doing there. Because sometimes we put the negative there, then it is only for the upper boundary, it is not for the lower boundary. So there I'm going to have my substitution. I don't know if that my substitution is going to be fitting there, but I will try. So it will be 3 to the power of 4 all over 4, right? Minus 2 into 3, to the power of 3, plus 11 into 3 all over 2, minus 6 into 3. Oh, now, in that one again, so I'll have 2 to the power 4 over 4 minus 2 into 4 into 2, sorry, to the power of 3 plus 11 over 2 into 3 minus 6 into 2, sorry. This is 2, not 3. Right, substitution by 2. Once I've done that, then I'm going to get my answer here. So my answer here is going to be negative 0.25. You see? So if I did not have this negative outside here, my answer was going to be negative 0.25. And we're talking area, so we cannot have a negative area. That is why when it's below, we put a negative there, so that at the end, we get a positive value of 0.25 square units. I hope you get what I'm saying. If it was above the x-axis, no need for the negative. The negative is very important. It is telling us that this thing here is below, because I can check on my sketch. Do you remember we said when we're doing these questions, the sketches will be given to you. So you will have a sketch. You will definitely have a sketch so that you're able to see whether the graph is, the area is below or above. If I'm given that part again, what will I do? I'll do them separately, and from there, that part, remember, it will have a negative, then I'll have a positive and a positive added together. Okay, right. So please make sure that you understand what we're talking about here in terms of the area above and the area below. Every time you have area below, put a negative on your integrand. When you have the area above, no positive, no sign should be put there. So you must just do it straight. Okay. All right. Now we have a different question. Now we have calculate a lower limit of the definite integral. Now that's asking me to calculate the lower limit of the integral. If the area is shaded by that, the area is given 1 unit squared. So meaning that the area of this part that is being shaded is 1 unit squared. I need to find what is the lower limit. I need to find what is the lower limit. I think the sketch there was supposed to be given. The sketch there, it's f at x, it's equals to minus 2x plus 4. Right. This is given. So this is given. That graph here was supposed to be given there. So it is the x minus 2x squared plus 4. Now let's see. If I write my integral, which is minus 2x plus 4 of dx, then I have the upper limit, which is 3, but I don't know what is my lower limit. But I know the area. The area there will be 1. Okay, I'm going to write it in the next one. So which means that if I integrate this, I'm going to have negative x squared plus 4x. The upper limit is 3, the lower limit is x, but the area is 1 square unit. Now I'm going to substitute. So when I substitute here, I'm going to have, remember when I substitute, I have this, I have that equals to 1. Then I'm going to have negative into 3 squared plus 4 into 3. This side I'm going to have negative x squared plus 4x because it is the x. So I'm substituting by x, so I'm still going to get the same thing. Then I know here I'm going to get 12 minus 9. 12 minus 9 will give us a 3. This side, can you see the negative is now affecting everything inside the bracket? So I'll have a plus x squared minus 4x, that equals to 1. Then I'm going to have x squared minus 4x. And now look at this. Nice to see. This area is below the x. Now I'm working on this. So what should I put there? Negative. Because the area is below the x. Or I should have put it that side or this side, does not matter. But now the area is below, so it must be negative because now I'm solving for x. So now if the area is negative, so if I take that negative this side, it becomes a positive 1, so it will be positive 4. Then I'll have x minus 2 and x minus 2. That equals to 0. Therefore, my x value will be equals to 2. You see, so it means that that lower boundary there will be 2. So the area between 2 and 3 of that straight line will be 1 if the lower boundary is 2 and the upper boundary is 3? Interesting question. I think you must also go and check it. Very interesting. Where we're given the area and then we need to get to the upper boundary or the lower boundary. Okay. All right. Now let's check the last question. The last question is basically the same thing. I'm given the lower boundary, which is 1. Now can you see what the examiners are doing? They give you a coordinate now. You must know we're working with the x values. Now they confuse you with that one also. All right. Now, but this is nothing. So what we need to do, we know the equation of the straight line. We know the lower boundary and the upper boundary. They just need us to, we need to calculate the upper boundary now, the upper limits. So the upper limit is B, we need to calculate B. Is the area given? Yes, the area is given. Same principle that we've used in the, but now in this case, what is our area? Is it above or below? It's above. So we have the integral of, there's a B there, and we know that there's a -1 in the lower, and then we have x plus 1, then we have dx. Oh, that's quite easy. Then we know when we integrate that, what do we get? X squared over 2 plus x integral b and -1. That area equals to 8 square units. And what do we do? We substitute. So I'm going to have b squared all over 2 plus b. Then from there, this is, remember, this is minus. On the other side, I'm going to substitute by -1 all squared over 2 plus -1. That equals to 8. So work out that I'm going to have b squared over 2 plus b. Then here I'm going to have 1 over 2 minus 1. So what is 1 over 2 minus 1? I'll have a negative value here. So if I say a half minus 1 will give us -1, minus half times a negative there, it will give us a plus half. That will be equals to 8. And maybe let me finish it here. I'm going to have, if I multiply throughout by 2, easy for me to multiply throughout by 2. So I'll get a b squared. Multiply this by 2, I'll get a plus 2b. Multiply this by 2, I'll get a 1. Multiply this by 2, I'll get a 16. So I'll have a b squared plus 2b. Then I'll transpose the 16, then I'll get a negative 15. Then I think this can be factorized, so I'll get b and b there. I think it's 5 and 2 and 3. So my b will be, the signs there will be, this one will be a positive, that one will be negative. Then b will be equals to -5, or b will be equals to 3. So then I have to choose one between the two. And how do I decide? Go to my sketch. Remember I said the sketch will always be given. I go to my sketch. -5 will be that side. But there's no shade in that side. 3 can be here. So I think that can be 3 for me. Okay. So b is equals to 3, I have it. I can say therefore b will be equals to 3. Then this one I discard it. Because on the -5 side there's no shading. But if I go to maybe 1, 2, 3, I might get that to be 3. So that will be 3, b will be equals to 3. Because that's our upper limit, and the upper limit will be a 3, the lower limit is -1. Boys and girls, let's look at the preview for the next lesson. Just in time on the 20th, that is next week, Wednesday, from 14:30 to 16:30, we'll be doing another interesting topic, which is circles, angles, and angular movement, which we have done in grade 11. We'll be revising everything. Please tune in for that lesson. It will be very, very, very interesting. to remind you of things that we have done in the previous grades. Please prepare for this lesson so that then you also have to go through everything that you have done in grade 11. And thank you so much.